So hello everyone. So in this class I am going to discuss about what is electrostatic shielding and dielectrics. In this two types we will get polar dielectrics and non-polar dielectrics, and explain how the net dipole moment is developed in case of polar dielectrics as well as non-polar dielectrics when it is placed in the electric field. Okay. See now electrostatic shielding. See electrostatic shielding means, so the electric field, from the electric field it is getting shielding. Okay, from the electric field if I want to shield the electric field, it is called electrostatic shielding. Okay. See now suppose if I take a conductor, okay, so if I want to protect this conductor from the electric field, I need to do the shielding. Okay. So if I do the shielding means if there is a presence of any electric field, its value not get affected. Okay. So this is called electrostatic shielding. Okay. So definition is, it is a process in which the cavity of the conductor is shielded from outside the electric field. Okay. So this is called electrostatic shielding. It is also called Faraday cage. Okay. So it is also called Faraday cage. So Faraday cage means, so it is a case which is used to block the electric field. Okay. So suppose if you are traveling in a car during raining and there is a lightning. Okay. So another situation, if you are standing below the tree, in which case you will say, so you will feel safer from the lightning. Okay. So everyone will say, obviously, so inside the car you need to stay. Why? Because see the car acts as an shielding. Okay. You will get shielding from the outside. Okay. So if there is a lightning also, so that lightning it will get neutralized from the outside. Okay. So that's why, so during lightning, so don't stand below the tree. Okay. So now see next concept is dielectrics. See, for the conduction of electricity, for the conductors, see it contains some charges, right? See why conductors will conduct electricity? Why? Because see in conductors, so not only in conductors, conductors, insulators and semiconductors, so there is a presence of valence band and conduction band. Okay. See valence band and conduction band. See suppose if we give the energies means this electron will change from the lower energy state and to the higher energy state. So that's why it will conduct electricity for the conductors. Okay. So for insulators, this energy gap, so this energy gap is very large. Okay, so that's why it will not conduct any electricity. For the semiconductors, it will stay midway between conductors as well as insulators. So it will conduct electricity, but it is not up to the mark. But so these are the special type of insulators. Dielectrics means these are the special type of insulators. It will transmit the electric field but without conducting the charges. Okay, this is called dielectrics. Okay, so what are the dielectrics? So dielectrics means these are the special type of insulators which conduct the electric fields but without conducting the charges. For example, we can say mica and quartz and pure crystal. Okay, mica, quartz are the example. Okay. See these dielectrics are of two types. First one is polar dielectrics or polar molecule, and another one is non-polar dielectrics or non-polar molecule. Okay. So now see here, so polar molecules means the center of the positive charge and center of the negative charge do not coincide. Okay. So it is called polar dielectrics. So non-polar dielectrics means the center of the positive charge and center of the negative charge coincides. It is called non-polar molecules or dielectrics. Okay. See now in which case the dipole moment will develop. See here for the polar molecules we have the distance. Okay. See suppose if I consider the distance, this one is A, this one is A, so I can write it as 2A. So distance is there. So if the distance is there means obviously I will get a dipole moment P. Okay, but it is not equal to 0. So what is the dipole moment formula? P is equal to Q into 2A. For the distance should be there. Okay, distance is must. But in case of non-polar molecule, the center of the positive charge and center of the negative charge coincide. Here there is no distance. So there is no distance means obviously there is no dipole moment. Okay. So for example, for the polar molecules is water and hydrochloric acid. Okay. For the non-polar molecule or the dielectrics, the examples are, so H2, N2, O2 and CO2. Okay. So now next concept is, so I explain how does an electric dipole moment is developed in the polar dielectrics when it is placed in the electric field. Okay. See now I will consider a polar molecules. Okay. So what are polar molecules? Polar molecules mean the center of the positive charge and center of the negative charge do not coincide. Okay, so center positive negative charge stay away. Okay, so this is in the absence of electric field. Okay, so this is the condition in the absence of electric field. See, so the net dipole moment is 0 here. Okay, the net dipole moment is 0. Okay, see, so suppose if I place these polar molecules in the electric field. Okay, so what happens? So this the charges get separated, polarization will happen. Okay, so polarization means the separation of the charges will happen. So if it is positive, positive means here there is accumulation of negative charges, here there is accumulation of positive charges. Now here the net dipole moment is developed. Okay, so this is in the presence of electric field. Okay, so this is in absence of the electric field. Okay, so similarly, so this is for the polar molecule. Okay, so now if I consider a non-polar molecule. Okay, what is non-polar molecule? So non-polar molecules means the center of the positive charge and negative charge coincides. Okay, so here the center of the positive charge and center of negative charge coincides. Here the net dipole moment value is 0. Okay, suppose if I place this non-polar molecule inside the electric field, so what happens? Again there is a separation happens, or polarization will happen. Polarization means the separation of the charges. Okay, so here negative charges will accumulate, here positive charges will accumulate, here net dipole moment will develop. Okay, so this is the concept. Okay, so thank you.